Yeah, excellent. Perfect. Cool. Thanks so much for the introduction and the opportunity to present my work here or present my this particular talk here. So today I'll talk about vibe checks and red teaming, why ML researchers are increasingly reverting to manual forms of evaluation. And in particular, I'll be talking about the open problems with automatic benchmarks that may be behind this recent trend. And as I said before, happy to be interrupted by any questions you may have. Yeah, I would love to keep this interactive if you would like to. Let me dive in. Yeah, there we go. So, yeah, hopefully fine. Yeah, so quickly, what do I mean by ML eval is going manual? There's been a bit of a counterintuitive trend recently, which is that some of the ML developers that are developing the largest models, in particular kind of people working on large language models and the likes, are increasingly doing a lot of manual evaluation in the form of red team. And these are people that typically, right, they're focused on automating all sorts of other tasks, yet they're doing quite a sort of manual way, or they're putting a lot of effort into manually evaluating their systems. And sort of what is red teaming is maybe an important point here to discuss. So red teaming is kind of borrowed from the security community, is all about basically these researchers hiring workers to manually try to test and break the systems that they develop. So they basically hire a lot of people and they then manually try out the different systems that they develop. And so that's kind of on the red teaming side. And you see a similar trend that are kind of more on the user side of things, where a lot of users of LLMs report that they do kind of refer to vibe checks to decide which LLM to use, as opposed to kind of using a more rigorous or sort of more automatic benchmarks. And so in vibe checks, people, instead of looking at a benchmark, they will actually like try out different LLM assistants and then kind of check their vibe with that system and then kind of decide on it. And in particular, when it comes to the red teaming side of things, this is not just for fun. This is not really something that these labs are doing just on the side, but rather you can kind of infer just from the sort of public reporting at the public kind of websites that these companies put out, that they do kind of invest sizably into these kinds of manual checks. And I've kind of pulled out two kind of public reports by OpenAI and Anthropic, two of the labs that develop some of the largest models. And you can kind of see that OpenAI themselves say that this is an integral part. Red teaming is an integral part of their iterative deployment process. And similarly, Anthropic is also kind of saying that they make significant investments in red teaming in its models. So there's a sizable kind of effort of manually evaluating these models, and sort of from people that otherwise would really be likely to automate or try to automate these kind of systems. And I think this trend hints at challenges with the sort of main automatic alternative, and that is kind of ML benchmarks. And this in its own right is not necessarily a problem. Like, so it's just that these model developers use a lot of human input to validate their models is actually maybe a good sign. It becomes a problem if you really rely on this, if there's no good alternative, and if you aren't able to scale things up, because that's a problem with manual evaluation. I'll go into this in more detail, but it's tricky to scale this up as you kind of deploy these models more widely. You want to check for more use cases, for more model qualities, but also if you want to check for more sophisticated capabilities, you will also hit some boundaries. Okay, so I think this should kind of motivate, and this will bring me to the goal of the talk, that it's really important to have really good automatic evaluation alternatives to these more manual approaches as well. And yeah, and so the goal of this talk is for me to kind of take a first step towards this, having these better automatic alternatives, and that is really clearly identifying what the problems are with current benchmarks and what what is going on. So the question I want to answer is, what are the problems with benchmarks that may explain why parts of ML, a field that's dedicated to automation, is reverting back to these forms of manual evaluations, or why these manual evaluations are having such a big, are so widely used. And sort of a few caveats here, just about the kind of context of this talk. I'll primarily be talking about LLMs and the sort of variations of that, and large multimodal models, LMMs. So whilst a lot of the benchmark problems I'll discuss will kind of also extend to other parts of machine learning, my focus really is on those types of models, and that's where I'll draw the examples from. And then also, it's not going to necessarily be comprehensive. The focus is really to give an overview rather than a full list of all the problems. Hopefully, it's a helpful overview, but I can't claim this is going to be a comprehensive list of all the problems one might have. Cool. With that, and before I kind of go into the actual talk, I want to give you a quick outline of what this will look like, how we will discuss, sort of go through this question and try to answer this question. First, I'll start off kind of putting my talk into context, like what is some related work that's relevant here as well, and where does my talk fit in, and the sort of corresponding blog post that I'll link later. And then I'll go into a quick introduction to what's a benchmark, so we're kind of all on the same page of what we're talking about, like what do I actually mean by benchmark, by automatic benchmark. And then sort of in the second part, I'll go into really the core part of this talk, which is all about sort of the problems with LLM benchmarks. I'll start off with 4 problems affecting sort of individual benchmarks. So this is more on a sort of, you give a benchmark, it either has that problem or it doesn't have that problem. And then the last 3 problems I'll talk are more about sort of the ecosystem, sort of on a broader level. And then finally, I'll kind of try to conclude the talk and kind of draw some lessons from all the problems that we have seen. Cool. With that, let me get started on the kind of related work. And the idea here is really to just put this talk a little bit into context. So there's lots of kind of comprehensive surveys out there of LLM evaluation, which try to kind of capture the entire field and what everybody is doing, which I think can get quite overwhelming and kind of difficult to draw very concrete lessons out of. And on the other hand, you have sort of blog posts. This one here is by some people at Anthropic, Ganguly et al., which give you a little bit more of a sort of practical kind of experiences of benchmarking these problems, which is also very interesting, but maybe a little bit too little structure. So this talk and sort of the corresponding blog post kind of lies somewhere in between there, giving kind of being based on experience, but also giving a bit more structure and really trying to provide a clear structured overview of what are the open problems with benchmarks. Yeah. So that's so much for the sort of related work. Now let's really dive into it with a sort of quick intro into what actually is a benchmark. What do I mean by language model benchmark? So a benchmark is an automatic evaluation tool that aims to test for some form of model quality. So I like to illustrate this as this sort of flag that lives on top of this sort of surface of possible model qualities. Each model quality is this sort of cross here. And then so in this case here, we have the model quality of the ability to code. Then you may have a benchmark living kind of on top of that. That's human eval as an example, that is aiming to, in some form, measure that model quality. And so that's kind of the illustration I'm going to use throughout the talk. So kind of get familiar with that. Yeah, and so benchmarks really provide a very important signal whenever kind of developing machine learning models. They, in some form, provide a signal for which model may be better, in quotes, than another model, or exhibit a certain quality that is desirable or undesirable more than another model. So you can make decisions about which model or which architecture to continue on. So that's kind of more on the individual ML developer side. But then it also provides this form of synchronization across the field, as many here will be very familiar with. It allows for people, without actually reproducing everybody else's work, to put their work into the context of all the other related work in a certain field. And so I think this is a really important function of benchmarks as well, and has been essential, I think, for ML research for that reason, because it allows this sort of efficient synchronization of the field. And comparison, it's not without its flaws, as we will discuss. Like, these are very imperfect, inevitably imperfect systems, but nevertheless, it's really an essential tool for developing ML systems. And nowadays, benchmarks are really used beyond just the model developers, which sort of for a lot of smaller fields that are more primarily research, that would be the case. But now as these systems go out of pure like research settings, you really see a lot of other people also looking at benchmarks and using these systems. So you have like downstream developers. Those would be people that don't necessarily want to adapt and create their own language models, but rather they will want to use them for some other application. They maybe have a very concrete use case in mind, and they want to test that language model for that use case. Then you maybe also have end users, as I alluded to, who sometimes may prefer a vibe check, but these end users may also look at the benchmarks as well. Then sort of maybe a much more recent addition, this would be something like policymakers, people who are trying to understand the space as sort of there has been the hype. People are trying to pay very close attention, understand what's going on. We also refer to benchmarks. And maybe another group that I haven't really added here, but may also be quite relevant, and we'll see it kind of plays into some of the other fields, would be something like a venture capitalist, people trying to invest money in the field. They may actually use benchmarks as a point of reference to make decisions about where to put their money. So that again puts pressure on benchmarks in various ways. Okay, so that's so much for the sort of overview of what a benchmark is. Now I want to give a more concrete example of the type of benchmark I'm talking about here. So I can kind of refer to something that we all know. And for today, that will be the human eval benchmark, which basically is a benchmark for the ability to write Python functions. It came out in 2021, slight difference. And it's a very popular benchmark that consists of 164 Python functions with Python function signatures and docstrings. So it's something like what you see here. This is one particular example from that benchmark. And basically the task in this benchmark is for the model to look at this Python function signature and the sort of specification of the function that comes in this docstring. In this case, you have the sort of string message, and it's supposed to be encoded in a certain way. And then the task in this benchmark is for the model to complete this function according to the specification. And then the benchmark has a bunch of unit tests associated with each of these Python so function beginnings. And the way you kind of get an output from your benchmark is you actually run it, you generate all of these functions, then you check all of the functions using the unit tests, and then finally you get like an output of how well a particular model may be at writing these sorts of Python functions. And the key reason why it's called human eval and not computer eval or something is because all of these functions were handwritten by a human at some point. And so that's why the name. I want to make a big important caveat here, which is that human eval was a great contribution. I'm not trying to pick on human eval specifically. I'll use it to illustrate a lot of problems with benchmarks, but these are not unique to human eval by any means. And I think human eval at the time it was kind of published was actually really influential and has kind of seen a lot of follow-up work that builds on top of it. So human eval is great. Just want to clarify that. Cool. Now, sort of in this context of explaining sort of benchmarking at a high level, I also want to kind of put it in relationship to manual evaluation. And I want to point out that in general, manual evaluation in machine learning kind of workflows, right, it's good practice as a sanity check. Like you don't just want to rely on benchmarks. This would not be a good strategy for developing machine learning models. That's actually, especially sort of, I used to work a lot with reinforcement learning models. There in particular, it's so important to have really good visualizations and really look very closely at the model output. So in general, really good practice. I'm not trying to discourage sort of manually evaluating ML models. But we see that sort of with LLMs, this is sort of this unusually high importance. So we see what we haven't really seen in many other ML fields, sort of entire leaderboards that are entirely built around sort of crowdsourced data, sort of manually evaluating things. So this is the LM6 chatbot arena leaderboard, which is very popular, which basically just lets crowdsources human users that try two different models and kind of rank them against each other. And that way they come up with this sort of leaderboard based on an ELO score. So similar to like a chess kind of setup. And that's a very popular way. And a lot of people kind of quite heavily seem to rely on these types of leaderboards for making decisions. And then, as I alluded to before, we see these sizable investments in these manual evaluation efforts by these sort of large labs as well. Yeah, and as I said before, it becomes a problem if there's no good alternatives. If we're really relying on manual evaluation alone, because the thing with manual evaluation, scaling is really hard. There are like if you want to scale your evaluation to more models, to more model qualities, to more use cases, you also have to hire a lot more people, and you have to pay a lot more people. And for certain use cases, you're just not going to find the people to even evaluate it. And that's in particular true when you talk about potentially superhuman capabilities or sort of capabilities that are very close to human expert level. There it will be really tricky to have a reliable manual evaluation process. Yeah. So I think this should really motivate us that we need this automatic evaluation alternative that works really well, that can augment manual evaluation. And the first step towards this is really being very clear about what actually is wrong with benchmarks, and then we can kind of think about how to fix it. Yeah, and so the first part, as I said before, is going to be about problems that are with individual benchmarks. So I'm going to start off with like 4 sort of common problems that are being discussed here. And so the first one I want to mention here is overfitted benchmarks. So this is quite widely discussed. Basically, you have models that are being overfitted to certain benchmarks. That effectively means that they may perform really well on those benchmark measures, but in the end, they don't generalize to the sort of underlying model quality. And there are 2 main reasons for this. The first one is data contamination, right? A lot of these models, they're being trained on these by just scraping web data. And if you're going to scrape GitHub or all sorts of other repos that contain benchmarks, you're also going to get along all of your benchmark data. So your model may actually memorize the benchmark results and like what was the correct answer, rather than your benchmark being a good kind of measure of the underlying quality you're trying to test. So that's a very common thing. There you're also dealing with sort of a misalignment in terms of incentives. Right, like if you are a commercial lab that is trying to develop models, investing into decontamination is going to make your scores perform worse. So like sort of why would you invest money in this if that makes your life much harder in terms of like raising money and competing with other companies? So there's a real disincentive. I'm not saying that anybody is necessarily doing this, but I'm just saying like the incentives here are not necessarily aligned. So that may also kind of make that problem worse. And then the second reason we see overfitting is because we the benchmark itself is being used for hyperparameter tuning, right? So for example, human eval, you'll find this in all of the model cards of like a GPT-4, of a Gemini, of Anthropic. And so you kind of see that these benchmarks are being used for almost advertisements. And so I don't have strong evidence for this, but I think in general, a lot of labs will use benchmarks to kind of make decisions around model, like which models to pick and which models to pursue further. And that again leads to kind of information about the benchmark leaking into your model, and your model will then kind of perform better or sort of generalize poorly around the benchmark and kind of overfit on that particular benchmark. And in either case, really, the result is that your benchmark is just no longer reliable. It doesn't really give you as much information as it used to before, as it used to maybe as it initially came out. And human eval kind of has both of these problems. So it has been around for a while. And so it will be in most of the training data sets, at least originally, if it hasn't been decontaminated. But it's also, as I mentioned, kind of everywhere in these reports, so it may very well also be used as a sort of measure for hyperparameter tuning. And I like to illustrate this as a slightly worn down, misused benchmark flag. Yeah. Cool. Okay. So the second problem that's quite commonly done or quite commonly discussed is saturated benchmarks. So initially, when you create a benchmark, you're really trying to cover a model quality that where you are able to separate top models. Like you're not really interested in what is shown here in green, which is model qualities that all the models exhibit. So if you now created a benchmark that tries to capture like spell checking for language models, like minor spell checking, probably most language models would be able to do that. So you wouldn't really be able to learn much about the models by having that sort of benchmark. And on the other hand, if you create a benchmark that is way too hard for any model to solve, equally, you aren't really able to obtain any information about the different models and how they differ from each other. So usually benchmarks are built somewhere in this sort of white ribbon here in between, which is kind of at the boundary of what's currently possible with models that really allows you to separate the top models. And as time progresses, models, at least in the sort of past few decades, have incrementally improved. And so eventually, even if a benchmark initially was really good at separating out the top models, you end up with benchmarks that are saturated and struggle to really separate out the top models. And so human eval, for example, is a benchmark that at this point may be considered as fairly saturated. It's obviously a continuous process. It's not like on and off, as it's maybe alluded to here. It's very continuous. And the impact of saturation is also that an increasingly small subset of the test cases usually separates out the top models. So effectively, if you're talking like Claude 2 is much better than GPT-4 on this benchmark, that may actually mean something very different from what it meant maybe GPT-3 being better than GPT-2 on the same benchmark. So there's sort of a difference in how you interpret results. And that leads me to the next problem, which is what I like to call misunderstood benchmarks, which is really all about that often for a given benchmark, it's people misunderstand, users misunderstand what the actual model quality is that the benchmark is trying to measure, or that it's actually measuring. And kind of levels of saturation, of benchmark saturation, kind of play into this because they also affect like what actual quality is being tested. Yeah, and so I like to illustrate this as sort of, this flag that's somewhat uncertain where it's supposed to go. And with human eval, as I said, you have this sort of saturation part. So you have like a relatively small subset of the tasks that are still kind of separating the top models, but you also have it being used to sort of in a very broad sense where it's just kind of understood to measure Python coding ability. And so, yeah, so that would be a classic example of sort of a misunderstood benchmark. Yeah.
I feel like in manual evaluation, we have one of these problems too, right? It has contamination, it has saturation, and misunderstood. Manual evaluation.
Yeah. So the point that was raised here is that a lot of these problems will actually be replicated in like manual evaluation. So like you may have something like contamination, and you may also have. Yeah. It's a good point. I think maybe in the benefit of manual evaluation over these sort of static benchmarks is that it's not static. So like if you really hire your workers, they will always try to they will always inevitably vary like what exactly they ask the model usually. I think that's kind of how that sort of data contamination issue might be tackled. But yeah, you may actually have them overfit to the sort of somewhat odd use case of red teaming versus other. Is that kind of what you?
The manual evaluation users are not trying to test these LLMs, right? And most of the time, the questions that they might ask are not in stress testing, in the sense that, I mean, I just tried analysis.org and I just started there, and then I saw. So like I would probably ask a very simple question, right? It takes a lot of effort. It's like none of us really trying to stress test LLMs, right? And so in that way, I think most of the queries could be in that data contaminated region where you're only testing those which LLMs already know very well about.
Yeah.
I feel like it also has all of these problems that you pointed out with human eval.
Yeah, I see how it definitely can exhibit some of. I can see how they exhibit some of it. I think it's to a certain extent it mitigates it through this sort of additional randomness, but I can see how it sort of you end up testing a small subset of model qualities, which is maybe a little bit what you're referring to, right? So if there is actually, like in depending on your red teamers and how you instruct them to do their thing, they may actually end up doing there's a lot of friction, so they're not going to go necessarily super deep in their questioning because that would be a lot of work. So yeah, there may be some weird effects with manual evaluation as well. But that's just one more reason why we really need to figure out the automatic side of things.
Right.
But yeah, cool.
So
Yeah.
Eval actually things.
That's a good point. So I think if it really depends, right? Of the difference between, I think it's really useful to think of the difference between two models. So I have actually looked quite closely. It's a little bit back, so I have to recollect this, but I've looked very closely at the difference between GPT-4 and Claude 2. And I remember sort of a lot of the test cases were these slightly ambiguously answered, slightly ambiguously posed problems that GPT-4 was just a little bit better at like figuring out like what was the intention, even though I personally struggled to sometimes figure it out. So that's kind of, I think, where human eval, sort of the top models on human eval currently are, is kind of really this subtle skill of like inferring like preference or inferring like the intent of the instructor. Yeah. Does that make sense?
So to properly understand a benchmark, you would sort of say that someone has to look at the specific test cases that they are using.
Yeah, if you really, really want to understand what you're doing, what you're testing, yeah, you really have to dive really deep. Yeah. And then you'll be able to go back and say like, okay, it is as I described just now, like this sort of broader model quality that is testing. But if you really want to understand what you're testing, you really need to look at the use cases or the actual test cases. Yeah, okay. Yeah, then the sort of the fourth problem with individual benchmarks that I wanted to highlight here today was expensive benchmarks. So here the problem is that just to run certain benchmarks, it's just quite expensive. It's pretty simple. And so that prevents sort of a, well, on the one hand, it prevents kind of reproducing results on benchmark because it's just expensive to do. But it also prevents sort of a wide share of model qualities being tested because it's expensive. So you kind of limit yourself to what you test. And there are two main reasons why benchmarks may be expensive. The first one is it requires a lot of inference compute, like it's just a lot of test cases. So like some of the sort of classic NLP benchmarks, they have sort of large texts that they use, and that just requires a lot of inference compute. And therefore, if you were to use something like you wanted to check something like a model behind an API like OpenAI GPT-4, you will actually you have to spend a lot of money to just run a benchmark. And this is a problem that has kind of increased as these, right, like as models have become bigger, and so the cost of inference really has increased, ballooned. So this is really now, like all the benchmarks often are a bit more laissez-faire with like using a lot of data. Your benchmarks, I've seen a little bit of a tendency to kind of limit it a little bit in terms of what they use. And the second reason, and I think this one is not to be underestimated either, is that just for a lot of benchmarks, in particular, if it's not just a sort of plain text, but maybe it's like a coding development kind of benchmark, it actually requires a lot of development work to set up that benchmark. So I've seen this kind of so human eval is not too bad, right? Human eval is just you basically just have to execute some code. Ideally, you want to do that in an isolated kind of environment, so that's maybe a little bit of effort, but there's quite a good ecosystem around it that helps you to set that up, and that also helps you to just run all of the tests very automatically. But then you have other benchmarks like the SVE bench, software engineering bench, is kind of the next level, kind of more recent benchmark, which aims to test kind of more complex coding abilities. And there, you really need to set up, it needs to set up these entire dev environments, which have lots of dependencies and Python dependencies, and it gets really complex. And I've personally seen this a lot in sort of more on the RL side of things, where I worked on like building control with reinforcement learning. And there you have these building simulators, and there it's even messier in terms of like just having everything to set up. So whenever you build a benchmark, it's really important to keep in mind that to keep the overall setup simple and straightforward to use. Otherwise, nobody's going to really use your benchmark, and it will kind of become less relevant. And so human eval is really in this scenario I wouldn't say it's too bad. Obviously, it has all of the other flaws, so it may not be the perfect solution. Okay, so let me summarize this part of the talk. So in summary, we have kind of illustrated these four problems with individual benchmarks. So the first one is overfitted benchmark. This is really where benchmarks are being misused, either by leaking into the training data or by being used as an optimization objective. Then problem number 2 was saturated benchmarks, which is really where, as time evolves, the models just become better and they can't separate the top models anymore. Then we have problem number 3, which was all about misunderstood benchmarks, kind of that people don't necessarily understand what is the underlying quality that's being tested. Saturation plays into this as well. You may not actually know what exactly is the test cases that separate the top models. And then kind of problem number 4 was kind of expensive benchmarks, just being really expensive to run these benchmarks and that limiting kind of the amount of use of benchmarks. And in particular, I think this, maybe on that last point, it's worth mentioning that, right, like as kind of the relative proportion of the cost of manual evaluation versus automatic evaluation is really important here. And I think this plays into why manual evaluation now seems like such a good option for all of these labs, is because of this expense of running some of this inference. It just makes more sense than it used to maybe with smaller models a few years ago. Yeah. And now to the sort of bigger sort of ecosystem problems that don't just affect individual benchmarks, but are a little bit broader in their scope. And so the 5th problem here I wanted to mention is missing benchmarks. So right, that there's infinitely many model qualities you may ever want to test in for your LLM. And there's only ever going to be a finite set of benchmarks that are out there. So for that reason, for most model qualities, you're not going to have a corresponding benchmark. And so this is exactly what we say. So for example, I don't actually know whether this is true. I don't think there's a benchmark for the ability to write jokes. Maybe there is, but it's definitely true for many of the new use cases. In particular, this is very relevant when you have these multi-use systems where a priori it's not really clear what the downstream uses are. Then there is actually a lot of areas where we don't actually have the benchmarks yet to test it. So we actually now see a lot of new benchmarks being developed, and kind of the NeurIPS benchmark track it's kind of a good example of just the amount of work that is going into tackling this problem of missing benchmarks. So much for the sort of missing benchmarks. Now, another one that I think is a very important problem is unfeasible benchmarks. And this one here is all about like how complex of a model quality are we currently able to evaluate. So I kind of alluded already to this kind of line. So I mentioned human eval, right? I introduced this in the beginning. Then we have the software engineering benchmark, which is slightly more complex to test. As I alluded to, it's also more expensive to test, like in terms of dev time. Where this is actually using real GitHub issues, basically sets up that entire dev environment and then asks the model to solve a real GitHub issue, and sort of that was successfully merged previously by a human in a pull request, and it uses all of that data from that original pull request to test it. So it's a little bit of a unique use case where we have that data and they are able to really have that really quite advanced skill out there. But then when it comes to doing the sort of open-ended job of an entire software engineering role, you will struggle to find a benchmark that exists, and you'll also struggle to probably build it right now, just because of the kind of setup that this would require in terms of like simulating a team and simulating all of the sort of actual requirements that come with a real-world role. And so kind of how can we test really advanced capabilities is an entire field of study, which is kind of what the kind of scalable oversight in this area is trying to do, is really figuring out how can we evaluate very advanced kind of capabilities. But that's at least my perspective on this field. And I think this is exactly kind of trying to tackle this problem of currently unfeasible benchmarks. Yeah, and then problem number 7 is what I think is actually also very important when you try to understand why there's all of this manual work, is actually aimless benchmarks. So a lot of times I think people aren't really sure what model qualities that they actually want out of their models. This is a massive problem here for these multi-use LLMs, that the companies that built these, they aren't really quite sure about how they want to use these models. And they sort of, as an alternative, they can kind of just pick up the benchmarks that are out there and try to run them, but it won't really correlate necessarily with the downstream use cases. And I think red teaming allows to implicitly define like the use cases, or kind of do it at a very high level, because effectively, eventually, the workers in your red team will have to figure out like how they do to decide which model is performing better than the other, and they will have to make a lot of judgment decisions around which model qualities are actually more important than others. And so I think red teaming in some form is sort of an implicit definition of the desired model qualities. Yeah, and that's one of the strengths of red teaming. That one of the reasons I think why it's so popular. Yeah, so that was kind of the main 7 problems that I wanted to cover. There's obviously more. I think another problem that's widely discussed is kind of the issues that come with these language models being offered kind of as a service on the web, so that you don't actually, if you just access these via an API, you don't really reliably know that you're dealing with the same model one day after another. And that obviously also leads to downstream consequences when you talk about benchmarks, like what does it mean GPT-4 being better than Claude 2? What is the time, like when is this being done? And things become very time dependent with this kind of setup. But you don't necessarily even know whether they aren't doing some A/B testing, and there might be 2 separate models being served by the API at any time. So I don't know this, but I think there's lots of questions around the validity of benchmarks and kind of these kind of results that come from API usage and this setup. And then the final kind of problem that I wanted to mention here is just brittle benchmark. This may be kind of related to the sort of misunderstood point that I made earlier, but it's all about that language models, they generalize in a different way from humans, and sort of you have many cases of people showing that minor prompt variations lead to completely different results, and that obviously also affects the validity of various benchmarks as well. So if you're trying to build a benchmark, you probably want some variation in your prompts. There's a whole lot of work around this kind of problem as well. But I think it's kind of related to misunderstood, but you could potentially put it in there as well. Now, the scope of this talk really was primarily to talk about the problems that sort of really clearly give an overview of these problems, but I also want to very briefly kind of mention what I'm actually working on, which of these problems do I actually actively work on. And so my work really focuses on problems number 5 and 6, which is sort of missing and unfeasible benchmarks. And kind of the approach that I'm taking is that the one thing that's different now in terms of developing benchmarks from a few years ago is that you have also these access to these large language models and their sort of reasoning capabilities. And I'm trying to use these LLMs as part of the evaluation pipeline, kind of in order to scale up evaluation beyond what was sort of previously possible if you with the sort of more manual ways of evaluation. And so the first project here is kind of tackling missing benchmarks, so the sort of the generation of new benchmarks for where there's no current benchmark. That's kind of what I call a benchmark init or benchmark init agent. And it's all about kind of given sort of a model quality, how do I initialize a benchmark? How do I get started on a benchmark? For that new use case, how can I get started? And then kind of maybe iterate on this. But yeah, sort of as a first step, as a tool for that. And you can kind of validate that by checking it in areas where you actually do have benchmarks, existing benchmarks, and you can kind of try your benchmark init agent on those test cases. Still kind of ongoing work. And then project number 2 is all about sort of unfeasible, currently unfeasible benchmarks, in particular as kind of a subset of unfeasible benchmarks. And that's capability proximity metrics. So measuring proximity to very narrow capabilities. So in some scenarios, in like safety related contexts, you may really care about one very narrow capability, like having a certain, like being able to synthesize a certain drug or something. Then sort of current benchmarks generally they have a broad set of tasks, and it can be tricky to come up with a sort of continuous metric of how close am I to this dangerous capability. And so that's one set of benchmarks that's currently tricky to do. So maybe not strictly unfeasible, but not really well solved. And that's another kind of area where I'm that I'm working on, but this is also ongoing work. It's also collaboration with a master's student in the engineering department. Cool. Yeah, with that, I want to conclude the talk. Yeah, that's good in time. And kind of just quickly run through all of the problems so you kind of have them at the top of your mind as you go out of here. So the first one was overfitted benchmarks. That again was just like either sort of misuse of benchmarks, either by data contamination or by using them as an optimization objective, saturated benchmarks, kind of just not being able to separate the top models, misunderstood benchmarks, being not quite sure what model quality they test, expensive benchmarks, just expensive to run. Then missing benchmarks, again, was where we just don't have benchmarks for certain model qualities. And then the problem 6, unfeasible benchmarks, is all about like figuring out benchmarks for these advanced capabilities or sort of areas where benchmarks just aren't able to measure things that like this sort of narrow subset that I'm working on. And then problem number 7 is aimless benchmarks, which I think is, again, explains a lot of the sort of red teaming effort, that it's actually really hard to figure out what exactly are the model qualities we care about. And this is kind of an ongoing process of figuring this out as these systems get deployed. Now this is the end. Oh, no. Okay, good. But it is very good. So that was perfect. So this is, yeah, so this is brings me to the conclusion. So this is very close, slightly too early. Yeah, so I've introduced these 7 problems with benchmarks.
You're still on Zoom, just fine.
Okay, yeah, I think it's the projector. It's too long. Okay, I'll quickly wrap up. But basically, I've introduced these 7 problems with benchmarks that may partially explain these sort of rise in manual evaluation. And I think it's really important to be aware of these. And this is really why I wanted to give this talk. Whenever you use benchmarks, so whenever you want to be aware of the pitfalls that you may run into. But in particular, it's especially important if you develop benchmarks, then you should really try to actively kind of mitigate, be aware of these problems and mitigate them where you can. And then obviously, and this is kind of also where my work is, each of these problems also presents a research direction in its own right. And I think there's a lot of really exciting and important work to be done in tackling these and really making sure that we don't just rely on manual evaluation, but we really are able to augment it with really functioning automatic benchmarks. Yeah, and that is it from me. Thank you very much for your attention. I'll just very quickly say a big thanks to Samuel, Rob is here, and also Benjamin for the things. And a quick ad as well, if I may just. There's a CL AI safety reading group starting soon. So if you're interested in evaluation safety, reach out. Yeah, Jason and I are gonna be running that. So let me know. Cool. Then
Thank you very much. Questions and comments?
Yeah. We'll start with John.
Yeah,
That's right.
random question.
Go for it.
In mainstream AI competency testing Europe, the like, I don't think there's a lot of artifact evaluation goes on compared with, say, systems conferences, where most of the system conferences, most papers are reproduced by artifact evaluation committee. Now, the excuse would be the crazy number of papers, but that also explains why you can't get stable benchmarks, because the papers are just all over the place and the comparisons are hard unless they're trivial, which there are papers that are trivial. So how are we going to change the culture to fix that? Because there's some technical things which I think is great, it's a really good research agenda, but there's also a cultural thing, which is people generating far too many epsilon
fair.
papers to actually give a chance for people to learn what would be their comparison. And I'd say, in the systems community, we include adversarial evaluation as part of that aspect evaluation. Means you really know where things don't work well as well as, yeah, this paper does what it says, but they didn't try this thing. Oh, look, it's really terrible, which is really starts to get you in that of design specs. So I just wonder if there's anyone putting an idea about how you fix the culture, divide the number of submissions by 10%.
PhD students here may not be happy with that. But
basically, we use impact.
True. No, that's fair. I think, yeah, I could just second. I think it's a really important thought but I don't really see how sort of the current trends of like just more relatively small, just the inference costing so much would make this sort of reproducible and like, yeah, reproducing it as a default in the conferences feasible kind of in the near term. But I agree, like there's definitely some culture that could be kind of copied in some form, ideally. I don't know if there are any other thoughts on this.
More comments or thoughts or questions?
Or also questions.
Is that the question?
Yeah, sure.
Not something you've directly talked about here, but in the paradigm we see today where I think almost all of the top models use some form of reinforcement learning. How do you think that fits in with benchmarks and like this insistence on aligning our models with human preferences in whatever way that means? Does that change the way we should be evaluating?
Yeah, I think that the fact that we use, so maybe I'll just repeat the question, but so it's all about like how the fact that we use a lot of human preference data and reinforcement learning from human preference to train the models and how that affects benchmarks. I think it's a little bit of a symptom of this problem of we're not quite sure what model qualities we care about. Like we're entering this sort of very complex space of uses which we aren't able to describe as well as we used to. Like sort of there's no MNIST for like a chatbot assistant. Like we can't really say, well, what's good. So I think it connects to that. But yeah, like kind of I think there's a lot of interesting work to be done in terms of like extracting from actual usage data information about like what are the model qualities we care about, what are these preferences, can we describe them more explicitly, and then maybe come up with automatic evaluations on top of that kind of data. But I think this is very much kind of an open problem at the moment.
Do you see a lot of people reaching out to like the more interdisciplinary way? Like, for instance, if you're doing a therapy, more that they'll get that testified from that profession, and do you think that would then extend to all different subject fields? Because I know before they had this thing called conversation design, that they would like design chatbots that have specific voices depending on which company they're for. And that would be based on whatever company wanted before, right? So do you think it's actually just it's too much being done in one discipline rather than not being taken care of within the disciplines that they're trying to talk about?
Yeah, that's to repeat the question. Yeah, so it's all about like the question was about whether sort of a lot of benchmarking is just happening maybe in machine learning, as opposed to whether there should be more benchmarking happening kind of outside of the sort of core machine learning areas, but rather kind of in the application domains. I think I just don't really have a good overview of how much is happening outside. I can tell it sort of from my view, from my perspective, but I may be missing things. A lot of it is more isolated kind of machine learning people kind of figuring out kind of the use cases and kind of reinventing the wheel maybe to a certain extent as well. I think definitely this is like a whole research direction is it's just finding really good data in another field and kind of bringing it into machine learning and having a useful kind of test for a new use case. I think you definitely see that at some point. Any other questions?
Can you give me a sense? So you mentioned expense of running that. What the cost of that is relative to hiring a red team of a certain size versus
okay, good point. It really varies a lot, but I can tell you, so for example, I can give you maybe a back of the envelope estimate for something like a human eval. If you wanted to run, so it has 164 test cases. These are it's a very back of the envelope, but I think human eval with GPT-4 you will be able to run for less than $10 for sure in terms of API costs. But this is kind of but then when you sort of other benchmarks, you rack up like potentially hundreds of dollar kind of bills just for a single benchmark. I've at least seen this. I have done this mistake once of I was developing something for a benchmarking tool, and then I thought, okay, how expensive can it be? I just kind of ran a test case, and very quickly it just like used up all of my credits. I luckily had like a boundary of 3 credits, and it was only like $20. But so if you can very quickly use up kind of cost there. But that's obviously kind of, if you're talking about APIs, it will be different if you're in a company and you're renting kind of GPUs. But in general, so you can kind of see that these numbers are not completely different. So if you do a lot of this may like pay for a person over a year eventually, if you test like a lot of models a lot of times, yeah. But it varies. Like you for smaller benchmarks, maybe much less, and especially if you're not talking about the most expensive models like GPT-4, then it also gets a lot cheaper. Right? Like I think GPT 3.5 Turbo is something like a 20x less expensive. So the numbers really vary depending on what model you're talking about. Does that make sense?
So would you say it's generally much cheaper to run a benchmark than to do human evaluation or manual evaluation? Or are people running like thousands of benchmarks?
It's a good question. I think it can be cheaper. It certainly can be cheaper if you're able to emulate the sort of human quite well, but it varies. Like you have to be mindful. Like with sort of modern models, you can't just like mindlessly throw like more and more tasks at it. Like you need to choose like which tasks to throw at it. So yeah, you need to be careful. And this is something that maybe it used to be much less so, I think, in terms of like, I know it's like from the reinforcement learning area there, like you would spend, like you would really have so many simulations just to benchmark stuff. This is something you wouldn't do anymore. Yeah.
Yeah, I guess with the expensive benchmarks thing, then is that more of a issue for like end user evaluation rather than like company evaluation? I can imagine an end user wanting to do it for tasks is like not going to hire a red team.
Yeah, I guess, yeah, for the individual side, I think a red team, it doesn't have the same reproducibility, right? Like that's another issue of like being a red team, right? Like you can't really do exactly the same red teaming exercise over and over again. So you may not have that track in your organization if you're really trying to keep track of your models internally as well. So I think that's a big one. Yeah.
So if I understand correctly, you were presenting issues mainly with static evaluation, where you give a problem, you get the answer, and that you evaluate that. Have you thought about looking at the interactivity with the language models? Because I think that really affects the evaluation and how the models perform. We've done some work on this in maths, in particular, about how LLMs work in mathematics to
Okay.
interact.
Yeah. So that's definitely that's a big kind of research direction as well. Like exactly like sort of going beyond just like a one single kind of interaction, like static, where you have one interaction, but instead kind of having like conversations. And I've actually played around with this, like having also like LLMs talk to each other and kind of maybe see if by instead of like having 10,000 like tests that you run on, maybe you can extract much more information about a model by just having a bit of a longer conversation where you really dig deeper into like whatever model quality you care about.
I can send you a link to because we did empirical studies.
Absolutely, yeah.
Large numbers of mathematicians and also qualitative studies on.
No, absolutely, yeah. I'd be very, very, very interested. Awesome. Yeah.
On the direction you're working, first point.
Yeah.
Somehow using models to improve evaluation. Is there a paradigm where you can use the best model to evaluate the best model? Is that practically feasible today or in the next 5 years?
You mean in this? What do you mean by that? Sort of the best one?
Whatever's best now, GPT-4, and we want to evaluate GPT-4. Can we do that with a LLM-assisted evaluation benchmark approach?
You mean in the sense of like what's the ceiling of what you can evaluate? Yeah. So the goal would be to be able to evaluate GPT-5 with GPT-4, right? That's the ultimate. That's really what you want, and that's a little bit what scalable oversight is all about. It's like, can you have this sort of weak to strong supervision? Can you use a weaker model to come up with sufficiently complex tasks to be able to evaluate effectively a model that's maybe a few steps ahead of the current model? So that's definitely the goal. And I think this really depends on the model quality in my experience. Like sort of for certain areas, this may be easier to do than for others. So like in coding, for example, you can kind of maybe create very complex programs and then take some complex programs, introduce some bugs, and then you may be able to test like you may be able to do this with a simpler model, and then you can test maybe a much more complex model that that would have to then find these bugs. So you have these sort of asymmetries that you may be able to use to have this sort of weak to strong supervision, but it's tricky. And I think in particular for some sort of more open-ended like text-based domains, it can be quite tricky. Yeah, does that kind of go in that direction?
Okay, well, thank
Yeah,
you
yeah.
very much.
Yeah, no, thanks.